They got some dark soil here in southern Minnesota, man. It just looks rich.
It is.
Look at that black soil. Rich looking soil. I mean, there's probably fields for miles in there.
Well, we got a grid road, usually every mile. Sometimes they're 2 mile by 1 mile.
Like I'm seeing patches of trees.
My sugar bush is right over there.
Oh, yeah?
A mile. You're probably seeing my sugar bush, that big one there in the distance.
What town are we in now?
This is Brownsdale.
We're there.
We're there. And they're right on the west edge of town. So.
Okay.
The story goes, the guy that started this had a construction business, right? And I'm assuming you do things that you're good at, and then people ask you to do other things, and you just say, yeah, I can do that. You know how a business evolves.
And there's a lot of smart business owners. I'm not one of them, but Clayton Christie is the kind of guy that can make a tunnel boring machine.
So they come up to a road one day, and the guy says, they were excavators. They said, we got to get across Highway 14. You're going to have to dig a trench. And they looked at each other and said, there's no way, it'll take 6 months to get a permit to go through that road. And they went home in the shop and they developed this 3-inch pilot tube system. Once you get the 3-inch tube through the ground, then you can pull reamers.
I got you. So there's a pilot hole.
Yep. And then they're able to do multiple things.
I mean, it looks like a spaceship. I looked online last night.
Yeah, so here it is. And they are worldwide. So this is the world headquarters. And
cool.
Those are flags where they are boring or have bored. And it's, what the size of this town is, 300?
Yeah.
So I don't know. Things like this is kind of cool.
That's cool.
It's really evolved.
This is it, buddy.
Mm-hmm.
Probably one of the best in the world at what they do.
I think they are. I do. I'm sure there's some other good ones out there, but they have 50 years of a track record.
Right.
That just...
Yep, they probably screwed up a lot to get here. That's what happens. That's how you get good.
You learn.
Yeah.
All right, let's go see if will take us.
All right, so we're here at Akkerman, and Joe actually talked his son into letting me come in and make a tour. Now, clearly, he's got his mother's looks. Clearly. So we're at Akkerman, and they make tunneling equipment. They're international. We're at their international headquarters.
That's right.
And they've got models and everything. So we're going to take a tour through the plant. Cameron's going to give us a tour.
Yeah.
So.
Cool.
So over here, this is the corporate office. Obviously, there's a lot of pictures. These are all projects. These get updated
As you do more projects.
every once in a while. This one's pretty cool. This was in Inuvik. That guy spent 2 weeks up there. So he went up. They drove him up to the Arctic Ocean one day when he was up there. I think he said the high was like 25 below or something like that every day.
Stuff just doesn't work as well when it's cold like that.
Right. So a lot of cool pictures.
I keep wondering. I was checking your website out, and I just want to know how they got the material out.
We'll show you. I'll show
I'm
you.
like, how do they get the material out of there?
So
Sometimes
we're gonna.
it's a slurry.
I call it across the street, but we'll walk across the street.
Sure.
Here. On our way over there, over here is our training center. It's our training and development grounds. So
basically, right there behind the railing.
Yep. So it's basically like a raised garden bed.
I got you.
And we have put basically local dirt in there to create an environment like in the field, but we have bunks in there. And we can dig that out and then put different geology in there, so we can put cobbles or rock or...
So do you have like your own excavation equipment and stuff?
We have a little one. It's over in the shed over there.
I got you.
The owner, he's a pretty outgoing guy, so he's usually digging holes somewhere else.
I got you.
But it's around. So that is for one of our product lines. I'm technical service manager here. I started as an engineer, but now I manage our field technicians, and this is kind of something that I take care of. Was when we bring customers here, we'll do local training. We'll also go in the field and do training. So
cool.
This is our second year with that, and we it's usually
it's like Akkerman University.
Yeah, basically.
Come in and learn
we
how
like
to do
bring
it.
customers here. We like to bring everybody here, give them a tour. We do a lot of cool stuff here, which you'll see. This is part of our staging for one of our product lines. There's rock cutter heads there, lube pumps, and then power packs.
Can I see a rock cutter head real quick?
Yeah, well, I'll show you. We can look at them now, and then we'll look at them.
I'm just
kind
kind of curious. Are they diamond?
No. So we have equipment to cut anything from soft ground raveling sand, which just means like very loose, like
So they
beach
probably have
sand.
different drill bits, so to speak, for different material.
Yep, different tooling. So there's soft ground tooling and there's hard ground tooling. And
I got
the way
you.
that the hard ground tooling works is there's these discs and they roll. So as this spins around, each one of these discs roll, and it just impact or pressure fractures the rock, and then it spalls. So there's some science in how close and how many of these there needs to be on the head for how hard the rock is.
Cool.
And then there's different sizes. These are our little 6.5-inch discs, and I think made our biggest head had 13-inch diameter discs on there.
Cool.
So we have.
Does this one wear out the fastest? Since he just spins right there.
That one does wear out because it basically just spins in a circle. It's like a pilot hole. But the gauge cutters travel the furthest and the fastest, so they wear out very quickly as well.
Cool.
Yeah.
Nice.
But yes, that middle one.
Got little Kubota diesels on there.
The best. So this one's used, I think, or they're just not painted. But usually the ones that are kind of in that middle 2/3 is the best lifespan because they're making the shortest circle but not the tightest radius.
That's cool.
So yeah, we run electric and diesel
These are like
engines,
little pump
power
skids,
plants.
huh?
So we have Kubota, Cat engines, John Deere engines, whatever.
Are you
fits our
building these
package.
little skids?
Yep. Yeah.
So what are the skids for? That's just like water.
This is a lube pump. So there's bentonite mixture. It's bentonite is a natural clay. A lot of it's mined in Wyoming.
Okay.
And you can add that to water, and then you pump it in on the outside of the equipment. It's a lubricant in the annular space, so your jacking tonnages can be reduced by pumping lubricant in there. So this is
it's lubricant like what when they frack, they use lubricant in the water as well, just a different application.
Yeah, and these are for our pilot tubes specifically. So as our pilot tubes go in, I'll show you inside. The head's 5 inches diameter and the tubes are 4 inches, so you have a 1/2 inch annular space around that. It's also to remove spoils. So as you're pumping this in, it's got to go all the way up to the head and then come back out the hole. It helps keep the hole open, stabilizes the ground. So we make all the lube pumps here. We power them with diesel engines, and then our power packs are diesel engines and electric motors too.
That's
Need
cool.
a generator to do that.
Look I love diesel engines.
We got all sizes of them here, from I think 25 horses up to 250
Those
horse.
look like Kubotas, and then these look like 3-phase motors running off a generator probably.
Yep.
Very cool.
So
like
these are our bentonite and lubrication pumps. There's 2 tanks, so you can mix in one while you're using the other one. So you're kind of batching them, so you're not ever running the tank empty. You need to wait for it to refill. And then, like you said, one is you run off a generator electrically, and one you run off it just depends what the customer wants. If you want to run, you're always bringing diesel to the job site anyways.
Yeah.
So if you have to fill up equipment, excavators, generators.
And the bentonite, I'm going to go back to the bentonite real quick. That's basically a natural lubricant. Mm-hmm. So you're just using dirt from another part of the country as your lube. Yeah,
we can add polymers and other things to it that help aid in the suspension of the material and kind of gels it some. There's a lot of different things. I don't know a lot about it, but there's a lot. Bentonite, there's guys who, their profession, we call it, they're mud guys, and their profession is understanding the chemistry of the ground and how all of that interacts to put in the right mud to get the right outcome. And so a guy does that full time, and they're usually very, very good at it. And if you want to have a successful job, you usually find a guy that really knows what he's doing.
With the chemistry.
Like our techs know some of what the recommendations are, but that guy, he'll come and figure out the chemistry to make sure everything's stable.
I got you. Huh. I know some guys like that.
So we'll go inside. I like to do the flow of raw material and then to finished products. So we'll walk down this way and we'll go start over there.
Hey, that looks like mine.
I just watched one of your 4
Oh, you did?
videos. Yeah. Yeah, after the live stream you did with the Satmaster tap,
Oh,
I
it
went and
actually
watched
did
some-
really well.
I watched a bunch of your sawmill stuff.
I love milling, dude.
Yeah, I've been
It's
thinking
way-
about buying one.
It's
and I was
way
gonna
more
talk to
fun than
about
you
it.
think it is.
Is
That's
it?
what I, yeah. Anybody I'm trying to help them with their spouse.
I just don't need another hobby.
I know. But that one's fun. And I got a helper that helps me, really does it all.
Yeah.
So,
Yeah, your dad helps you. Is that
my dad does it in Austin. I got a good helper.
so? Yeah, this is a plasma cutter and then an oxy torch too. So depending on the thickness we cut, we use the different cutting.
I got you.
This building was built in 1967. There's every once in a while there'll be like tags up there when the building was built. This company is 51 years old this year. We started in 1973. The owner is still around. His son is the president. He's the third generation.
Well, how old's the owner? He's still around. I mean, 51 years, he's got to be in his 80s, I'm guessing.
No, I don't think he's that old. He's probably only 70.
Oh, cool.
I'm not exactly sure, but his dad started. He was a general contractor.
Okay. I'm thinking the original.
Oh yeah, sorry. He has passed.
Okay.
The Don D.H. Ackerman was the original owner of the contracting company.
I got
and
you.
He has passed, and then he made the first TBM, which I think is actually over there. It should be kind of cool if it still is. You can film that. And that was
What's a TBM?
Tunnel boring machine.
Okay. So I guess it is faster to say TBM.
Yeah. Yeah. So if I say any of that, let me know.
I will.
So I think it's over there. We just repainted it because we're donating it to the Historical Society, the County Historical Society.
It's like one of the originals.
It is the original Akkerman, and that one was built, I think, in the late 60s.
Cool.
And then eventually Akkerman Manufacturing started, and that's what Maynard started in 1973, and he's run it until recently. Justin, his son, has taken over as now the president.
I got you.
I just saw him. That's who I was looking for.
I got you.
So this was the original building. Actually, there was a building up here, and that's where engineering was, is in this little room up here.
Yeah, I got you.
It's some of the building's been tore down.
Half of a shipping container.
Yeah, I don't know if this story is true. A customer told it, and I like to believe that it's true. And way back in the day, there was a trailer house that was the main office, kind of where you guys parked. And they were looking for Don Akkerman, I believe, and they came in this building, and there was pigs along that back wall. And he said, that can't be it. I got to walk over there and talk to them. So he walked over there and said, I'm looking for Don. And he said, go back in that building. And he's in that building. He said, the one with the pigs? And they said, yeah. So they were welding in here, and there was pig pens, I
That's
believe,
awesome.
on the far wall.
Dude, I believe it.
I think so, too, because
I
it was a
believe it.
farm. Like I said, it may not be true, but I remember a customer saying it
Well,
at
the
one of my
reason it's true is
anniversaries.
it's totally something I would do. Any business owner.
Yeah.
We got our
Yeah, you
hobbies,
gotta
man.
diversify and
Yeah.
use your space, right?
Or you'll go crazy doing the same thing.
So these days, this is our raw material initial processing room, is what we call it. But this is where all the raw steel comes in. So
So
we have
everything
big,
starts here.
yeah, big racks of all the bars and rods, and then we have some pipe and casing, tubing stuff up there. Two big saws here, and then that's all plate steel.
I got you.
And we can cut up to 8-inch thick plate here with that oxy torch, and it goes on that plasma table
I
here.
like your platform on that I-beam there. The rolling platform.
Oh, yeah.
That's cool.
Yeah, so we have a bunch of big overhead cranes
Bridge
here,
crane.
capable of lifting pretty heavy. I think this one's maybe 15 tons. The ones on the other end of the building are 30 tons.
Okay.
And we can couple them so we can lift 60 tons.
I got you. Yeah.
So he's just doing some small stuff now, but
That's all right.
that's probably a
This is
3.5
plasma
inch plate.
cutting?
Yeah, he's plasma cutting there.
Just not a fabricator, but I've been in a few shops. That's cool. So
I
it's
think-
following a computer program.
Yep, CNC plasma table. That's probably maybe an 8x10 table. There's another story, I don't know if I verified it, but the owner one day walked through here and they were putting a 6 or 7 inch plate on that table. This was a long time ago. But he said, make sure you don't screw that plate up. That costs as much as a new pickup. So the big heavy plates are on the far end there, but you know,
It's
there's
like
a
a
lot
special
of steel
alloy.
in there. No, it's just regular mild steel, but it just, that plate is, that's what that plate costs. It's
I
a lot
got
of
you.
money, so, and that was probably 15 years ago.
He was probably adding in the shipping costs, I'm thinking.
Yeah, probably. We're lucky. A lot of our steel, I think, comes from just probably 20, 30 miles north of here. Probably not even that far. McNeilius Steel is where we buy a lot of our steel.
And they're probably getting it from steel mills across wherever.
Yeah, they're a big steel
service.
distributor.
Okay. Well, they got to get it from probably Pittsburgh.
I'm not sure.
A lot of steel made in there. Well, Chicago
I
too.
think that guy can go anywhere.
Yeah.
So-
yeah.
We'll go, there's kind of a Y in the road here, but a lot of stuff, we'll go to the machine shop here for a little bit, and then we'll go over to weld, and then we'll come back to
Cool.
assembly.
Oh, I love this.
So this
Room Rich on steroids.
Yeah.
I don't know where our, so right here, 1986 is when this portion of the
Cool.
the plant was built, and there used to just be a little breezeway between where the welders would be in there originally, and then the machine shop was in here. And we've obviously grown a pretty big building here, but
This is cool.
so we do probably 90 to 95% of our manufacturing in-house. These days, we're getting busy enough, we started outsourcing some of the more volume stuff just to help our production flow. But we're really proud to do a lot of our stuff here. Almost all of our engineering's done in-house as well. The engineering department's upstairs in the mezzanine.
Do you do any laser tube cutting?
No.
Do you outsource that?
We don't have a laser tube
Is it-
cutter.
what's the
We don't-
volume like?
We don't do a lot of it. When we have done it, we use it for jigs and fixtures because
Okay.
we want them to be more precise. We're fortunate here that we can have a little more tolerance in our, I shouldn't say this so absolutely, but we're fortunate in some parts of the manufacturing process we can have a little more wiggle room where the flame table over there does just fine, and then it
I
gets
gotcha.
welded together, machined. So that laser is a lot more precise product, but they cost a lot of money too. So
I
the
got
little
you.
bit that we do, we outsource.
I
that.
got you.
Yeah. So every one of these machines, you'll see the name up there if you want to take a quick shot of it, and the year that we got it, and then the capabilities. The capabilities
That's
are on
awesome.
there too.
I wish
so,
every company did that.
yeah, like I
Because
said,
now it's based on everybody's memory. You know what I mean?
Yeah,
So
so
you
we-
guys have it documented.
we really enjoy bringing people in for tours, and we bring a lot of high school kids in that want to be in the trades. We
I
probably
got you.
bring in, on average, one a month or every 6 weeks probably. We bring tours through
Cool.
to expose kids to our industry and what they can do for jobs locally.
Yeah.
So we made these for the anniversary parties, and then obviously tours that helps when I don't have to remember all this stuff. But you'll kind of see if you peek at
I'm
them
gonna
as we
definitely
go
get
by.
those shots. That's cool.
Yeah. So that's a CNC mill. This is a CNC lathe.
Kumas. Look at this. That thing's huge. That's a big boy.
Yeah, so we'll go all the way to the end, then we'll come back
Okay.
is what I'll probably do. We have, just for small stuff, we'll have some manual stuff. We use that. I would say it's as busy as the CNC stuff, but mostly just because the small volume stuff is, it just takes time, right? So you're making manual
Yeah.
stuff slower than you're making CNC stuff. So we probably don't do equal number of pieces, but this stuff's, any day all this stuff's running. So this is new, I think as of about last year, maybe a year ago or March or something like that. This is it's a vertical lathe. What we had here before, they actually put it in the ground, and then they built the building around it, and it was an old manual vertical lathe. We have a smaller one down there. It was from the 40s. It made, if I remember correctly, it made tank turrets for World War II. It came from the cities, and we bought it, and we make a lot of big round stuff. So that's why you'll see some of our equipment's very specialized for big round stuff. So I'll go stand over here for scale of how big this is. I don't think we have a decal made for this yet, but this is I think it's a 4-foot table there.
This is cool. Now, do you have one of those machines that checks how round it is? It's got like a probably in your
the
quality.
robot arm right there. Is that what you're talking about?
Oh, okay, yeah.
So that we call it a roamer. It's just a brand name, but that's like a mobile CMM. They call it.
Okay.
Can't remember what CMM stands
Me either.
for. Coordinate measuring machine or something.
Okay.
So basically, you can go touch off at all your parts and then do quality control. But apparently, we just got a really nice laser scanner.
I got
That is still in the boxes. We haven't opened it for Christmas yet, but the machine shop manager, when he gets back from his hunting trip, is going to inventory all that to make sure we have the stuff. And then we got a very nice laser scanner, I guess, so we'll have that for quality inspection and the laser
where you
scanner.
got that?
The laser scanner.
Yeah.
In that room over there. It's all in
No,
the
no, no.
box.
I mean like the manufacturer.
Oh, I don't remember. I could ask Jeremy. He
I'm
probably
just curious. There's a company in Youngstown that makes it.
Yeah, Jeremy'd probably know.
Doesn't happen to be M-Tech, does it?
No, it's not that.
No, I don't.
So Nate's here. This is Nate Bissell.
How you doing? I'm a maple syrup farmer / YouTuber.
Nice.
Yeah, so-
they said you were coming in.
Yeah, my dad and I patented a maple syrup tap, and Nate is here filming a video on how that was made yesterday. So he wanted to stop by and just see some local
Yeah, this is pretty
manufacturing.
freaking cool.
So I just I asked Justin if he could come in and film, and he said that he could. So I'm just showing him around. He's making a little video.
Yeah.
And there's some laser scanners. It sounds like made near you.
Yeah.
And I can't remember. Alex said the name. It's a
Youngstown
weird
area.
name. So
I'm sure there's several companies that
anyways,
do it. Yeah,
I could go look at the box. It's in that
not-
room over there.
I was just
but-
curious.
Yeah.
So, yeah. Okay, cool. Thanks, Jeremy.
Hey, thank you.
So we got this in 2019. The turn diameter is 138 inches. I believe that's like 13 feet or 13 and a half, something like that. This is a pretty impressive machine. When we bought this, I believe there was only 2 of them in the United States, and
This
they were
sucker's
both
big.
in Boston. And they were making, I think, Inconel reactors for submarines, nuclear
Okay.
submarines. So my joke is always that when we bought this was the biggest of its kind west of Boston in the United States. So,
I got you.
this is it's
Through the tool? Is it they lube through the tool, or is this normal?
what's the question?
Oh, sometimes they do high pressure. The lubricant comes through the tool.
Yeah, I can
Some of this is through the tool.
Okay.
That's what it's doing now is not. He's just drilling a hole.
cool.
Automatic part changing CNC. This has got a live end mill and a single point tool, so you can spin that table at like, what's it say on there? 160 RPMs, which when you get something real heavy on there, big, it gets pretty wild.
I would say. And that's how they get the edge on.
Yeah. Yeah, so you're just optimizing the what tooling you're used to develop the part.
Look at a shot of this guy here. This is a good idea. Every manufacturer should do this.
Yeah, it's cool.
Otherwise, it's
it
just
really
memory.
helps me, and then if I forget to say it, I usually point it out, and then I don't look at them on every one. But
Very cool.
and then it was maybe a year or two later, we got this one. This is gantry mill, I believe is what they call it. It's
Gantry, like Gantry, like a gantry crane.
yeah.
Okay.
Yeah, I think
Oh, wow.
meaning that the gantry's all up there, so it's a big table. This is a 124 inch by 165 inch machining area. You can step up
Can I
there.
step up there?
Absolutely.
I don't want to frighten them.
And this is what my
Morning.
dad mentioned. You could
Morning.
Look at a
could-
shot of this.
Oh, cool. He's doing about the biggest part we make on there. Every time I visit you, Matt, you always got some puny little part on there.
How is it you're the largest mill and you're making this thing? That's smaller than a shoebox.
Timing.
So I guess you can
That's
see the
funny.
size of the table. That kind of like
So it can make something as big as this table.
Yeah, 10 feet by like 13 feet or something. 14.
But he's milling
No,
an
it's
ammo
16
can in
feet.
here.
Yeah, so he's just got that little
That's
that little
funny. That's funny.
pin thing for jack frame.
Jeez. That's like boiling a gallon of sap in a huge evaporator.
It's funny, every time I bring a tour through here, I was like, let's go up there and see what he's making, and it'll be
See
something
this-
like that size.
This massive part. Thank you. Let's go watch him mill this massive part.
So that's a mill. The other one's a vertical turning lathe. They're both obviously very big. When we get to the other end, you'll see why we have such big stuff. Some of our equipment's got a little bigger over the years, so we've just had to buy the capabilities to be able to be competitive there. They're not running them today. He's running these are casing ends. So
Grab a shot of this.
yeah. So this is just another mill. We got a lot of stuff packed in here. You can jump in there and film that.
How you doing? I'm in your space here.
Oh, no, you're fine.
So the Mazak came in 2014.
Yes, sir.
Man. That's a beautiful thing right there. That's how stuff's made. How long does that tool last? Quite a while?
It should last for all of the 20 parts,
I got you.
but being flame cut, it does get rough on it.
Does that make it harder?
Just on the cross.
So you've been here a few years?
I'm on my 5th year now.
All right. How come everybody in Minnesota is so tall? Wisconsin, Minnesota, everybody's tall.
I don't know. I don't know. I just got a good.
You got to be 6'5", 6'6".
6'7".
Yeah, you're up there.
I got a good view.
Yeah, you do. You look down at these parts. I'm looking up at them. Cool. Thank you.
You bet.
So this machine specifically is normally our pilot tube machine. I'll show you a pilot tube. Every once in a while we'll switch to these casing ends. We'll switch to those casing ends, and usually, so we're obviously a pretty well-established manufacturer, but one of the things we say around here jokingly is we're like a prototype company because we make a lot of big stuff. Our volume's just low.
I got you.
But the pilot tubes and the casing augers or the casing ends are usually, if you have to go 500-600 feet and they're 3 feet long, you need 200 of them. So we run the pilot tubes pretty much constantly. Same with the casing ends. Every one gets 2 ends, so we make a lot of high volume. So this machine runs a lot of high volume bulk stuff
that you're always going to need.
Yeah, when we were at 2 shifts, this ran like 22 hours a day.
Wow.
And it would make pilot tubes all the time.
So the pilot tubes are what the augers run through.
The pilot tubes are just like a pilot drill bit hole. So we poke those to the ground, and then a head and the
like
augers.
a bushing for the auger or something.
Then those follow the pilot tube
Okay.
with an auger, and then upsize the pilot tube hole and excavate that additional material.
I got to see an auger.
Yeah, I'll show you all this stuff. It's
What's this? Like
this is the pilot tubes. So there's I don't know if I'll be able to get these off.
I mean, they're heavy, huh?
These are like 77 pounds a piece.
Are they stainless or just?
No, that's just because they're recently machined.
There's a nice little
and then
flat spot.
So on this frame that puts these together, there's a hydraulic. There's a fork that comes up, and then we torque them. They're tapered thread, proprietary taper thread that we torque together. So when you take them apart, we have a tool that grabs those flats, and hydraulic will snap them.
This reminds me of fracking a lot. I gotcha.
Yeah,
so there's the thread.
So this.
That'll go to the job site. This will go to the job site.
Yeah, this
and
is
then the guys can move it around.
This is 100 feet.
I got you.
Pilot tubes, and then they'll move this around.
And then they can pull them off the end.
Oh, here's some that are right here.
Oh, sweet.
So this is the male end. If you film inside of here, there's an inner tube right here and an outer tube. And so we actually put our guidance target. The way we guide these is we look down the center of the tube.
Okay.
And there's an LED target at the front of the front tube where the steering head is. And this is filled with air, and then this annular space is where that lube's pumped through that I mentioned outside. So it pumps through there, and then it goes out the head, and it can.
So there's two jobs. This thing's doing a lot, right? So there's something coming through the center, the outside. This is where that solution you were talking about comes through. So is this rotating the head?
No, the whole thing, the whole pilot tube
thing
string
rotates. Okay. Very cool.
So this is the male side, and the female side.
So you guys drill a pilot hole before you put the big machine through.
Yeah.
Is the pilot hole the primary business? Or
for us, yes.
So the piloting, this is your primary business.
We have basically 3 main product lines with 2 smaller ones that are a lot lower volume. But it's called GBM, guided boring machine, and we make the guided boring frame and the equipment to install the pilot tubes, and then we make some equipment to upsize it, and then there's auger boring, and usually what happens is our customers will partner with auger boring contractor, or they are a contractor of both, so they will install the pilot tubes and get their shot through on line and grade.
So the pilot basically tells the big boring machine where it's going to go.
Yeah.
Okay.
So our GBMs are similar to like HTD, but we have better accuracy. So in our industry, we install a lot of sewer, sanitary and storm sewer, and it is very critical that is on line and grade very precisely, so it flows right. Just the same as you want your sap lines to be on grade, so you get your ideal flow. So it is very important that these tubes get put in on line and grade, and we can do that very accurately.
Okay.
And then we are following with bigger equipment behind that to put in the final diameter required for the finished product sanitary
That was
sewer.
the bigger, older one you were talking
That
about.
boring mill come out of FMC, out of the cities.
Okay.
When I went to
Now, hold on. Anytime these guys say the cities, they mean Minneapolis, St. Paul. So I'm trying to help you with the local lingo. It's Minneapolis, St. Paul. They just say the cities, right?
So in 1983, I was in trade school for machining. And we went on a field trip to the cities and we toured FMC. And at the time, they had about 15 of these in a row, and they were making the battleship turrets for like the Missouri
Navy.
Yes, and those turrets, they start on the bottom of the ship deck, and they go all the way through. So they were making, I think they were 12-foot diameters or 10-foot diameters, and then 4 or 5 stories would get locked together.
So it had I got you. They had to be anchored in there pretty good, is what you're saying.
Yeah, those guns start at the bottom.
Okay, I'm just thinking it's just sitting on top.
The turret's got those 3 big guns on.
I got you.
So
They got to get their shells up and down through there too.
I got you.
And that plant was probably 10 times this big. They rode around it in bicycles.
We visited the Naval Academy with my son about a month ago, and I learned that it takes like $30,000 just to turn an aircraft carrier.
I could,
Yeah.
30 grand just to turn it.
What a scale, right?
I mean, it's so big, you can't even think of it.
So this one here is the same as the one I mentioned down there, but the one that was down there was like twice as big as this.
I
this
got
one.
you.
And this one's manual.
All manual.
So
there's no
there's
computer on
Did you
it.
see these levers right here?
Oh, you need somebody with a brain running it then.
It's very archaic.
You pull these. I'm not gonna move them, but that spins, and then there's
You
just
never prank them and
there's
like
a
just
big
move
rack
it?
and pinion, or
I got you.
You know, a false screw.
That's what moves it in and out.
Yeah, and then here's the heads where the tools are mounted, single point tools. So we kept this. We do a lot of roughing. If we got to flatten something or turn the ID/OD, where this is a little more cost effective before it goes to the CNC machines, or we might rough something in here and then send it to weld. If we got a lot of our forgings come in a little bit scaly, the welders don't like burn and weld through that, so we'll clean it up so they got nice raw metal to weld through, so it's prep for them basically.
You could really prank a fella if he was on break and you start turning these dials.
Yeah.
He probably wouldn't like it.
Yeah.
Yeah, that's pretty thick material right there. Look at that.
That's a bulkhead.
That's what, 1.5 inches, 2?
Yeah, maybe 2.
It's pretty thick.
So our TBMs, our tunnel boring machines, we have made some of them so we can convert them to go into, we call it EPB mode, it's earth pressure balance, which means they can handle some water. Our microtunnelers inherently are designed to go under the water table. So that's a bulkhead to go under, to put in a 96-inch diameter tunnel boring machine to make it watertight so it can go under the water table.
I got you.
So they're obviously they got some work to do there. But that's what it is. It's the bulkhead off that we can operate it with moisture present.
I got you.
So this frame here is a 240 frame. These guys are on break, so if you see guys with their feet up now,
It's all right.
they're still working hard. It's break time.
Yeah, I know. These guys earn their money.
So this is a 240 GBM frame. This is there's a gearbox in here with hydraulic motors on the back that drive that gearbox.
And that's all fabricated here.
I got you.
The gearbox.
The gearbox is.
Yeah, so
No
then
kidding.
this is where the pilot
I
tube
see
will
it.
thread on, and then when they lock them up, this will come up and gauge those flats that you pointed out,
Okay.
and then it'll torque that together, and then we can push.
So the flats hit, that
Yeah.
tightens.
Yeah, and then there's
And then
hydraulic
this thing
rams.
slides on
yeah,
like
there's
this.
hydraulic rams here. And
So
there-
basically, it
there's-
does a little at a time. You just keep putting in your
Put one tube in.
one tube in and
Yeah,
just
we
keep
can-
running.
Yeah, good operators and good ground can do about 100 feet an hour.
Okay.
Yeah.
Yeah, that's
So the
interesting.
pilot tubes, they displace ground. We're not excavating anything with pilot tubes. We're just ramming it through there. We can steer. We have there's probably a
And
steering.
then that slurry's coming out with the material.
No, this one doesn't.
Sometimes,
Oh, okay.
yeah.
This is just forcing it in there.
I got you.
Sometimes it is lubricated to stabilize the hole.
I
'Cause
got you.
We don't want
Vibration and stuff.
Yeah, so if we push it through, it's a 5-inch head, and the tubes are 4-inch. If it collapses back on there, it'll grab the tubes, and then your skin friction. So we rotate these and push them, obviously. So we're trying to reduce all of the friction while we go through the ground. So we will lubricate to stabilize the ground and reduce that.
I got you.
That's like theoretically, with no friction, you could push forever, right? So
Yeah.
there's something's limiting us from going 1,000, 2,000 feet. So we do lubricate. Some of the holes where
How
they
far
stick them-
can this thing push? Like I imagine this gets sunk into the ground or on a bigger.
Yeah, so they'll dig their shaft and they'll make the floor on line or on grade, and then they'll pour concrete or they'll put sheets behind there and put a big backstop so we can push real hard on it.
And then how many, like, I guess miles or how far can you push? I mean,
We can, so with this, 400 or 500 feet pretty regularly.
you.
600 feet's getting to be a long ways.
so this would be like going under a highway or
River.
Yeah, so
Through rock.
all of our equipment is designed to be trenchless. So any critical infrastructure that you don't want to disrupt traffic flow, or maybe it's a river, you can't open cut it. So the other ends of our product that we don't deal with, but the projects do, is open cut trenches. So that is dig a big trench and lay pipe in there. So we'll go
So
under.
if there's already a building, a city, something you don't want to mess up,
Yeah.
national monument,
Runway.
whatever.
A lot of runways, highways, railroad
Gotcha.
tracks. Railroad tracks we do a lot of stuff under railroad tracks, and they're very picky about how the product goes under the railroad track, because you can't have a hump in your track or a dip in your track after.
This would
So
be
it's
overkill
monitored.
for maple tubing. But you might, I mean,
Well, you could,
It'd be
but
freaking
yeah, it
cool.
would.
It might
It
be a
would
little
be.
expensive.
Yeah.
Yeah, I asked him to get sewer
Yeah.
from my sugar house
Yeah.
to the main. It's gotta go.
2.5 million.
It's gotta go whole block. And
Yeah.
that could be way too expensive.
Yeah, it's funny.
So we do have the capability with this product to do soft ground, and then I'll say like medium hard ground.
If
So
you
we
guys
have-
ever need R&D,
yeah.
like an R&D test site, I know so many farmers in the mountains that would sign up immediately.
So these are a product we have that'll do harder rock,
Okay.
or not crazy
So this
hard,
is like a
not
bit.
granite, but like this is a bit
It's
that goes on
replaceable.
the end,
That's
and this
cool.
is for like hard sandstones or limestones.
Gotcha.
So this is some augers there. This is the casing. So that right there's the weld. That end he was machining
I
just
got
back
you.
there.
I saw it. Okay.
And then this is the auger inside. There's a big hex drive. Those will all couple together.
And this
they
is
can-
just for the pilot hole.
This is the upsize of the pilot hole.
Okay, so you go small,
And then
then
a little
bigger.
bigger, and usually it's in steps. So some of the auger machines can do 72-inch augers, but you don't do that in one step. So you might go the 4-inch pilot tube to a 24 to a 48, then a 72.
got
So
you.
we call it like 1-step or 2-step, 3-step, 4-step. So this is those are roughly the same size. Those auger casings over there We have a PCH and a PRH, and this is the bodies for it. And this is the drive bearing, and then the hex drive there.
Jeez.
So this is
just a giant hydraulic motor then?
3 motors in there.
So it's planetary probably.
Yep, probably.
Yeah.
Just like the front of a Gravely tractor. The old Gravely's had a planetary in there.
So this isn't the best one to look at. Here's one too, but so the auger casings that we pointed out in that basket, you can see that same thing's basically right here.
Gotcha.
So this would be the next size up from that, and those augers will spin. Material now, when you upsize, this material will come into this size and go in here, and then the auger will auger that out. So this is a PRH. I believe this is a PCH. You can see.
So it's a little bigger.
Yeah, in here. So one's a power reaming head. PRH is a power reaming head, and the PCH is a power cutting head, and they're just a little bit different.
One cuts and one reams.
Yeah, and I think, well, I'm not sure about that. Anyways, these two will go together, but you see down here that same casing features on the lead of this.
I got you.
I don't know if you can get your camera
heck
in
yeah,
there,
man.
but it's different. You see it, it's a different, I guess, consumption than that.
I imagine you guys have learned a lot of lessons.
So the PRH, like you said, reams. This basically, you just push that through there, and it just be like, you're like pounding, nothing spins. It just goes and reams it through there. This actually has a little cutter head that spins, so the power cutter head.
So it's like a broach operation.
Yes, that's more like a broach operation. This actually has like a drill bit on the front.
See, our soils are way different than out east. We are 20, 30 foot of clay here, 40 foot of clay. Maybe some small rubble, sand and gravel.
Gotcha.
No of that hard rock that you see when you go out into the mountains.
Out in the east, yeah.
So
they probably
doing rubble.
You guys pretty much stick to the soil types and terrain that you are good at.
Well, this is our bread and butter. So this is where we started, but yeah, we've...
Like, you know your soil types well, and if it's like, certain jobs, there's probably certain terrains that you just avoid because it's not where your stuff does well.
Really hard stuff, but that's basically the only exception, and we're starting to get into that. We can do the whole envelope.
Okay.
Yeah.
Now, this has hydraulic motors, 4 of them, and that's probably turning a planetary in there?
Yeah.
And it's turning this shaft eventually, right?
Mm-hmm.
And
then that,
drive the other
yeah, that drives
this
the
hex
augers.
shaft is what's on the augers.
Yeah.
Gotcha. Jeez. A lot of hydraulics.
Yeah. You better know fluid dynamics.
Yeah.
So now down kind of this product line here is, there's 2 here. It kind of floats depending on how each one's busy, but this here is one of our tunnel boring machines is being assembled, obviously.
That's
this is
sweet.
We call it a 600. That's a 72-inch diameter machine. So that's 72-inch diameter there. This is...
Looks like a freaking space capsule.
We also call these conventional machines.
Okay.
They're kind of the... back in the day, they called them shields. And all that meant was that the structure shielded you from the earth. So when you're in there, you could be hand mining. There's a lot of hand mining in the United States that's still done today.
When you say hand mining, literally like a pick and an axe.
You push a steel casing in, and you go in there with 2 guys or whatever, and you dig it in with a pickaxe and a shovel.
Out the bucket.
Jeez.
So there's a lot of hand mining done.
You guys got, when you do this, you got conveyors to haul material?
So this is, right here's the steering joint. So the way this machine is steered is there's 3-point hydraulic cylinders on here, and if you extend or retract one of those, you can, if you extend or
so that's what's doing the steering is these hydraulics.
Yeah, and you can kind of get that front end to like wig around and steer. So there's a joint there.
Because it's got cylindrical shape. You can't just turn at a 90.
No.
You got to go
radius.
So when it'll like shake it so it can slip around the edge.
Yeah, so majority of the tunnels we do are straight. And the way we guide these is we shine a laser on line and grade, which is surveyed in. We shine a laser down it, and it'll hit the back of the cutter head, and there's a bolt in there, and they just steer that head up and down, left or right, to keep that bolt on the laser. Because you can imagine if the laser could cut all the way, maybe it's a 400-foot tunnel. These ones will go 1,500 feet, you get power loss at distance, so there's limiting
Gotcha.
factors there. But that laser, you could imagine you can make your absolutely perfect tunnel with that laser. Now you're just digging the dirt out to follow that laser to put your perfect tunnel in.
This is a 72-inch wide.
This is 72-inch diameter machine.
So is that
yeah.
that's 6 foot?
Yeah, it is. Yep. So this is what I was saying about being a conventional machine. Is this was kind of the early era. This is kind of the newer generation of the first machine I mentioned that's outside. But this operator actually sits in this machine and rides in it and operates it. So the operator will sit here.
Sure.
He'll sit here and
Play with the levers.
move these levers.
Probably does it. I mean, there's some finesse, but a lot of it's determined by the laser, right?
Yeah. Yeah, so one thing that's actually really crazy that I took a long time to understand is that this guy's running the head and there's a jack frame behind him that's pushing him, and there's another guy running that independently, so they have to communicate over
I got you.
radios basically, and he says start pushing, stop pushing. And what can happen is if you're stop spinning your drill bit, your cutter head,
And he's pushing.
you'll just cramp. You can wreck stuff really quickly.
Oh,
So it is
yeah.
a very elegant dance between those two operators
Gotcha.
to successfully put in a tunnel. The way that we get the material out of this machine, the cutter head has big paddles in it like a drying machine. And as the dirt comes in, those paddles load a belt conveyor. And a belt conveyor hangs from that winch, that hydraulic winch up there, and it belt conveyors it out and then puts it in, we call it a hull unit, but it's a little electric locomotive with a dirt bucket on it. So it's a little dump truck.
Yeah.
Basically,
Gotcha.
there's one right over there. We'll look at
Oh,
it.
cool.
So the head of this and the bearing, it might actually be over there, but this is a TBM hydraulic driven. That's the pump unit right there that I was mentioning. So
Okay.
so in the back there's
Hydraulic
another.
pump unit for this guy.
This is electric. So you hook it up to a generator, but there's two 200 horse motors in this that run the cutter head circuit.
This probably has a VFD in it, right?
This one doesn't. It's a manual stroker right here. So you just pull.
Oh, I
You
got
just
you.
pull that, and it manually strokes right there.
That's crazy. So they should just run out, dude. They don't. There's no VFD.
Understand
No.
it, basically.
I mean,
Yeah.
the electric. There's no.
So this is where
VFD.
the operator stands and runs, and he's communicating with the.
Oh, there they are. Those are just switch gear. There's literally no VFD.
Not on this. There's not.
Huh. This is freaking amazing. Look at those pumps. That's probably a reservoir there.
Yeah, that's a hydraulic tank there, and here's the pumps.
Probably have a spec on that, I'll bet.
So this is water cooled
You don't just go to Tractor Supply for that, do you?
for the pumps.
For the hydraulic fluid.
Oh yeah, you can.
It's
Yeah,
just
a lot of
regular
times if you have a
hydraulic fluid.
leak and we gotta go get oil to top off the tank, we'll find wherever we can. Tractor Supply or
Gotcha.
O'Reilly's or whoever has it. It's
SAE,
just a normal. It's
whatever.
a normal. Yeah.
I got you.
But they're water cooled, so this will get hooked up to either a cooling tank or a fire hydrant. And then we're building a lot of heat in here, so getting that heat out is important.
I got you.
And then this supplies all the hydraulic oil all the way down the tunnel to that head to run all the hydraulic functions in the head and spin the head.
I
So
see
like
every
said-
maple farmer's going to know what this is. They'll
I know it,
engine
right?
fitting, yeah.
There's some crossover.
Yeah, there is some
So like I
crossover.
said, that when you're running all that down the tunnel, you have line loss, pressure loss. So there is a limiting factor on how far you can go. But I think
Gotcha.
1,500 feet's coming kind of normal these days. We've really started pushing the limits over the last 10 years. Everything's doubled since I've been here in distance.
Gotcha. So this is your little dump cart.
Yeah, let's go over there.
It's got little rails or little. You run on a railroad.
Yeah, so what we do in the bottom of the tunnel is we have a track system. It looks like a little railroad track. It gets installed in every pipe.
Lights.
Yeah, I see that.
So there'll be a seat here, and the operator, he sits here and drives. This is,
Wow.
we make and design these gearboxes too. And then there's electronic controllers in here. This is a big battery. These are electric powered,
36
rechargeable.
volt.
they might 48. What's this? 1548. So that's a 15-inch rail and a 48-volt battery.
It's like what you put in our forklifts.
Yeah, I imagine these are sourced from some common place we just put them in here. So then this whole thing here, we'll get a bucket, a big kind of round bucket to match the idea. The tunnel be a little smaller.
And then the conveyor brings
it right in.
And the conveyor
comes in. This guy actually drives in under the conveyor, and the conveyor will stick up here.
Seriously?
Yeah, and then he'll fill that bucket. They'll take that out, and then a crane or an excavator will grab it, dump the bucket, and they just do that in and out.
You guys are turnkey, man.
So one thing I forgot to mention is, with us being trenchless, we're pipe jacking. So the way it works is we have short stroke cylinders or jack frames. We put in an 8 or a 10 or a 20-foot piece of pipe. So we will push that pipe in, and we'll set a new one in. We'll push the pipe in, we'll retract the jack frame, we'll set a new pipe in, and then we'll push. So the first pipe goes for the entire ride. The tunnel boring machine comes out the other side. The first pipe makes the entire journey. So you keep feeding
pipe in there. Do you weld it?
Sometimes, if that's what the spec is.
But also that
so we can
prevents
do fiberglass,
cave-in, right? Like it's
yeah, we
safety.
can do fiberglass reinforced pipe. We can do concrete pipe, clay pipe, steel pipe. Some of the smaller stuff, they'll do poly pipe, but we're not really jacking that. We're just making a hole, and then they're slipping that in behind
I gotcha.
it.
That's interesting.
So everything that goes in the tunnel's got to be at the length of the pipe that goes in. So you can't have a 20-foot stick if you only have a 10-foot pipe, because you have to match your joints. So the rails, the hydraulic lines, all that matches the pipe length.
I gotcha. So you can put it in and take it out.
Yeah,
if
so
you
that's
need to.
pipe jacking. And then all that infrastructure in the tunnel gets stripped when you're done. Usually if you do steel pipe, it's not the final product. Usually slip in another product pipe inside of that. It might be fiberglass or clay or something. But we can also install final product. So if you install concrete or fiberglass, it's just one pass and you're done. You'll strip all the infrastructure out and your tunnel's done.
This is cool.
So another product we make sometimes, that bulkhead machine that I showed you, that's going in a 96-inch diameter machine, and that's going to be a segment erector. So there's a jack can right behind that machine. So the machine is tunneling, the jack can's pushing here, and they're actually building the tunnel in the back of that machine. So the first piece you install doesn't move, that stays in the beginning, and then you're always building sections. They get on this, they'll get trolleyed in, and then they build a 4, 5, 6 foot section, whatever it is, and then they'll push off of that, and then they'll build another one right behind the machine. That's segment erecting. So that's kind of the two methods. Those can usually go farther because your jacking loads are transferred immediately to your head. When you're pipe jacking, you might have to push 2,000 feet of pipe that weighs 1,000,000 pounds, so not your whole jack force doesn't get to the head.
I got
So
you.
there's different ways to do that.
Conveyor right behind
So
you.
right behind you here, he's installing a belt conveyor that's almost done. So this goes and hangs on the center of the cutter head, and then this is what the drum loads, and then this loads it into that hull unit.
I got you. Huh. This loads it into this guy.
Yeah, here's a inner drum over here. It's not installed, but this will get installed inside of the head of the machine, and then when those paddles go around like a dryer,
and they clean it.
Yeah, or like a cement mixer or whatever you want to relate it to, but the conveyor's sticking in there out to like here, and then it's loading that belt conveyor.
So as this comes around, it'll put the dirt in the conveyor.
And then the conveyor puts it in the bucket, and then the haul unit drives it out.
I got
Once
you.
that bucket's full, you got to stop tunnel boring, haul it out.
Yeah, you stop while you haul that out, yeah. So now that's kind of our TBM product line. It's kind of our middle product line. Depending on the year, which product line we sell the most of is, it just depends on the market. But now we're kind of getting into micro tunneling. These are TBMs here still. They're just the conventional machines, but all of our power packs, we buy Connex containers, whether they're Bicons or Tricons or full 20-foot containers.
I got
And
you.
we put our power packs in there. They're easy to ship, and then they're weather tight too.
So you're building your kits.
Yeah, so in micro tunneling, this is our control building. So the operator doesn't sit in a micro tunneler This is the control building
For the microtunneler.
for the microtunneler. Now,
I
don't
got
know.
you. It's all right. I can see this. Switch gear.
So this is the operator station.
I got
So
you.
there's all the buttons and the knobs to run the equipment. So the microtunnelers get ran remotely. The microtunneler is capable of going under the water table.
Okay.
And then all the data from the machine is displayed here on the screen. So that there's a way more technology in a microtunneler.
Is it your team usually, or do you have companies that? So you build the equipment, and then you have companies that
We
separate
sell
company?
to contractors, yeah.
You
So
teach them. That's why you have.
We'll send the technicians out to train them how
I
to
got
operate.
you. That's why you
yeah.
have Akkerman University. You got to teach
Yeah,
them.
yeah.
Last times the technician, like up in the Arctic Circle, there was an Ackerman guy there for the whole time.
I got you.
Until they're comfortable.
I got you.
You're not going to pass off your 300,000 tap to a guy that's been doing 5 buckets.
Yes, true. True.
So we don't our big microtunneler that went up to St. Paul yesterday just left, and that would have been cool to be able to show you.
It would have been all assembled.
There's some stuff outside we can look at quick
Okay.
if you want. We're kind of wrapping up here. That's just another control building. Our big periphery drive machines, which our old series microtunnelers were a big electric motor, water cooled, bolted onto a gearbox, bolted onto the cutter head. Those are center drives. So we call them center drives, and those ran on 480. The periphery drives are what we are starting to move more towards now, and it's a big planetary gear, and there's a portal that you can unbolt. A lot of the drives are getting long enough that you want to be able to change the tooling on the cutter head underground, so you have to have a door to get in there. The periphery drive allows you to do that.
I got you.
So we're actually running 4,160 volts down the tunnel, and our big machines have a 500 horse water-cooled motor with a hydraulic pump stack on front of that, and then it's running hydraulics to hydraulic motors that run that planetary. So that right there is our transformer from 480 to 4,160 volts.
I
And
got
that'll
you.
go in a container too. So we have, for the microtunnelers, we have the control building container, hydraulic container, and the medium voltage container.
3 containers to run it.
Yeah, and then the machine and the jack frame.
Gotcha. Wow. There's probably some heat made with them babies.
Yeah, that's why they're water cooled. So the other thing that I didn't mention is the laser is how we're guiding all this stuff. We're pointing a red laser down the tunnel. It's not like the laser you'd play with your cat, but it's basically the same thing. The air temperature will affect that laser. Different air temperatures will make light bend. So we have to keep the heat out of the tunnel and keep the air from stratifying. We need to keep it well mixed and stable so that
So
that
the
laser
laser's stable.
behaves. Yeah, so the laser puts you where you want to be. And what we can see over 1,000 feet in a microtunneler, if you you'll actually see the laser, the hot air's at the top, cold air's at the bottom, so the laser will go faster in the top, it'll bend down. You'll actually see that if you follow the laser, your tunnel will actually dip down at the bottom, and it can be inches over
Yeah, but
1,000
inches
feet.
over a long, fraction of an inch is a screw
Yeah,
up.
so we have it's in this box, and I'm not going to be able to show it to you because it's very complex, and I would show you if it was available, but this is our advanced guidance system. We can do curved tunnels and long tunnels. My boss kind of came up with this design, and I'm in charge of it now, and I'm training the new guy, but we've done 2,305 foot tunnel with a curve. So basically there's instruments in there that look at each other, and they can look around a corner, because you can't bend light around a corner. But if I was standing over there and then my dad went and sit over there and you gave me a thumbs up, I looked at you and gave you a thumbs up, I could give him a thumbs up. So there's kind of a handoff that hands the
gotcha.
laser off to get it around the corner.
So you have to keep the tunnel temperature consistent, or
The
it won't.
temperature is not as important as just the mixture of the air is stable. So there's a big 12-inch vent line, and they'll blow thousands of cubic feet per minute of air in there to keep it cycled, just to keep the
So
air
that'll
moving.
keep it consistent.
Just to keep it moving and mixed up.
Gotcha.
Usually it takes about 45 minutes to an hour to do a pipe change, and that's enough time for the air to stratify. And when you turn the laser on and they turn the vent line on, then, because when you when you cut the tunnel utilities to set a pipe, there's no power, there's nothing's going up there. You have to unplug it all when you set a new pipe. And you turn the laser back on, you turn all the power back on, you turn the vent line back on, you can watch the laser move as the air stabilizes into turbulent air, because that stratified air is what causes the laser to bend. This is kind of cool. This is a Hall unit. It's a smaller version of what we looked at, but it's automated. So it's got sensors on there. It's self-driving. So there's a guy that's got to run the pump unit, the TBM, and the Hall unit on a conventional job site. So now this lets the Hall unit go in and out by itself. They just send it with a remote, and it goes in, picks up the dirt, the operator sends it out. So the one less operator in the tunnel. That can be a business decision, but it also is a safety decision. For OSHA doesn't really like to have people in confined spaces, and tunnels are confined spaces, so the easier we can make it to get people out where they're not in danger as frequently, this is kind of a product that we've developed to do that. He's painting the head of a TBM right now.
I got you. Very cool.
So we won't be able to go in there.
That's all right.
I don't know exactly how these work. You probably know better than I do, but obviously it's big enough to fit our biggest stuff in there, and then it warms up to, I think, like 95 degrees or something warm, so it can kind of cure that paint.
I got you. Yeah.
These are big transfer pumps, booster pumps, or feed pumps. So they're
You can pump some sap with those, Joe.
yeah, those are like 700 or 800 gallons a minute. Normally is what we'll run them at on the 6-inch lines with the big stuff. So one thing I forgot to mention, the microtunneler. It's actually, the way we get the spoils out is we pump liquid down, inject it into the cutter head, and it turns it into a mud, and then we pump the slurry out, and those are the pumps that do that.
Pumps.
So it's their slurry pumps. Yeah.
Gotcha.
So that's how we get them out of the microtunnelers, and we'll run 4 6-inch pumps.
So why don't I have a 3-inch line from my sugar bush to my sap house for 25 miles?
Yeah, I don't think you have the power there in Rose Creek, right?
Yeah, you need one of them at every house.
You dim everybody's lights as soon as you turn that on.
You need one at every house on the way into town, a pump to re-boost it up. So this is our yard where we store a lot of the stuff when it's done before it gets shipped to the customer.
These would be cool to see run, wouldn't they?
Yeah.
So
I really
don't know
see
many.
much.
I've been 80 feet under the main channel of the Mississippi, and I only know a couple guys that have ever been able to do that, and all of them are inside that building.
Gotcha.
So this is a 52.5-inch machine with a, we call it an increase kit, so we can actually, the base machine's not much bigger than this, but we can size these up depending on what the pipe needs to be. This is a microtunneler. This is the head, and that we call that a trail can, so some of the support equipment, you see one of those booster pumps right there.
Right.
But this is a soft ground head, soft ground tooling. This is a rock crusher.
Cool.
So this is the stationary crusher cone, and then these arms, you see there's different size notches in there to cut them out, and then a wiper arm. So as rocks come in,
it sizes them.
Yeah,
starts bigger.
This part spins, and it sizes them, and then the final size is these holes.
I got
And
you.
this hole is dictated by the size of the impeller on those booster pumps. So it's sizing it down, and then that's where the slurry is going in, and then it's sucking it out and pumping it in there.
So the pump will actually pump rocks.
Yeah.
Wow.
Gravel, kind of.
Yeah, gotcha.
So that's a kind of what a microtunneler looks like on the front. That's a center drive. This is a periphery drive. You see there's a portal in there.
In case they need to change the
the cutter head's not on here, but so this is a conventional TBM machine with a rock head on it. The little discs I showed you over there, there's big ones. They're not here. They're not in this one. But that's kind of what it looks like.
And this is a massive one.
Yeah, so that's a big one. That's what we call a closed face head, and that's for like raveling sand, loose flowing sand. So the nuclear symbol is not meaning danger. But these here are doors, and they're hydraulically driven. So as the ground gets looser or tighter, you can actually hydraulically close those doors. So at maybe the end of the shift, you want to close them so you're not getting ground flowing in. Or the ground's really flowing, you can make that just a narrow little slot.
And then you have to slip basically a giant pipe inside.
behind
Well, the
it,
pipe's
right?
getting pushed behind this.
So you have to bring it out the other end. You don't really have a choice.
We dig one shaft and another shaft, and we push shaft to shaft, or we can do reservoir taps where we push it into a lake.
Yeah, once you start, you're not coming back out the same hole
No.
because you've put the pipe behind it.
Yep.
I got you.
Yeah.
Man, this is awesome, dude. Thank you.
Yeah, you're welcome.
I appreciate
It was
it.
nice to meet you, Nate.
Yeah, I love it. All right, Joe and I just finished up. That was awesome.
Very impressive.
That was totally worth it. He said, you're going to like it. I was like, I don't know, Joe. What if we got a flat tire and we don't get to see the spouts get made? I was worried about the wrong things. But I'm glad I did this. It was very interesting, informative. Cam got his brains from his mother, too, I think. So I really enjoyed it, and I hope you enjoyed it, because that's something you don't see every day. And, hey, thanks for stopping by. Catch you in the next episode.